Yes. I didn't know they were on there. They're on the, sometimes I teach it with this section and sometimes I teach it with the other section. And to tell you the truth, I don't have a worksheet 2. Somehow it, oh, there it is. I found it. I found the worksheet 2, so we'll disregard that. All right, so Joseph's question was, on the worksheet 2, as we're preparing for the test, I see one about eigenvalue and eigenvector, which is number 21. And so that is not on your test. It will be on test 3, so we can hold on to that. And what I'll probably do is just copy that onto the test 3 worksheet when we get that. But eigenvalues and eigenvectors and characteristic equations will be on test 3 and not test 2. So please disregard number 21 on the worksheet. Okay, but before we get started with the worksheet, you have a homework assignment. Okay, I left the homework assignment because I took it home with me where I could play with it, and I left the homework assignment in my office. So if you have questions on it, that is fine. I'm just going to snag yours, and then I can go from that. Thank you. Do you have any questions with 1 through 10? Okay, good deal. So let me look through my notes and see if there's anything that I wish to cover. Okay, so I'm going to go through worksheet 2 and peep at that really fast. So the front page of worksheet 2 is just your basic information, adding, multiplying matrices, performing operations like multiplying by a scalar, adding, subtracting. B2, number 7, B2, we didn't really talk about that. And so when you think about B2, you don't, I say B2, B squared is what I should be saying. When you think about B squared, you think, oh, I'm just going to say negative 5 squared, 1 squared, 4 squared, negative 2 squared, but that is not how you work B squared. So the way that you work B squared is you don't, it's just like when you square a binomial, you don't just square the people in the binomial, right, the terms, you square the whole thing. So the way that you work B squared, and I won't work it all the way out, but I just want to make sure I bring it to your attention, is you take B and you multiply it times B, and so then you go across this one and down this one, you know, so like the first element would be across and down, I have to think. 25 plus 4. The first element's going to be 29. Okay? So again, the way we get that is we multiply these two, so we get 25, and then multiply these two and get 4. 25 plus 4 would be 29. So remember, you're not just squaring the individual terms, you're squaring the matrices, which means you write it twice. So just doing one more of those, let's go across and down and get this second position here. We would get negative 5 minus 2, so we would get negative 7 for that one. Remember that I looked to find the key. The key of this one is in Canvas. It's posted in Canvas. I think it's all the way worked out because I have the whole key worked out here in my notebook. All right, so that's how the front page looks. You do have a B inverse at the bottom. Did we talk about transposes? A9? Okay, we talked about transposes. So just refreshing your memory, as I'll refresh mine, A transpose takes the columns and writes them as rows, or you could say takes the rows and write them as columns. So A currently looks like this, which is a 2 by 3 matrix, 2 rows, 3 columns. So A transpose, you would take this column right here and write it as a row. 3, 4, negative 1, and 5. And so this would be 3 rows and 2 columns. So it also changes the dimensions there, and that's how that one would look. So row 1 becomes column 1 in the transpose, and row 2 becomes column 2 in the transpose. All right. I4. Find the inverse.
If you were trying to look for the answer for number 7, I got it right here.
Okay, thank you.
Just in case you would want to write it on the board.
Okay.
I did check with the graphic calculator.
Okay, nice. Number 11 is a fancy way to find the inverse Because basically what you're asking here is, let's fix that a little. What you're asking here is, what can I multiply by this so that I get the identity back? Okay, so that's how that one's going to look. And if you were, in your homework, in your textbook, they asked you this question, but they put something different here in this this I place here. And so if you did happen to see one like that, the way that you would set it up, first of all, you could recognize it's the inverse. And so you could find the inverse and do it that way. But you could also set it up this way. For lack of a, you could put any letters you wanted to in there. Okay, and you could set it up this way. So multiplying these first matrices over here, you would have 3x plus z, 3y plus w, negative 2x plus 6z, and negative 2y plus 6w. And that's what you would get on the left, and that equals 1001 on the right. And then you could go with your systems. 3x plus z would equal 1, because that's element 1, 1 on both sides. Negative 2x plus 6z would equal 0. Solve that out and you get xz. 3y plus w equals 0. Negative 2y plus 6w equals 1. Solve that out and you would get y and w. And so that's how that one would set up. It seems like it's been a while since we've done that one. Facts to know. All right, so on the facts to know, matrix multiplication is not commutative. That's important. If A is equal to its transpose, it's said to be symmetric. Okay, and so that's not something that we've talked about before. But if you think about symmetric, it comes from the word symmetry, right? And so something equal to its own transpose would be something that looks like this. Okay, so if this was A transpose would be writing this and writing this. So if A and A transpose are equal, that means it's symmetric. And so I think of it this way. If those two are the same, when you write them as the transpose, they end up being if those two values are the same, it end up being symmetric. Singular. Singular means that it doesn't have an inverse. Singular means that a determinant equals 0. And upper and lower triangular, I'll show you those. I'm not going to ask you upper and lower triangular on a test, but I will show you those, where we'll at least get those covered. They are definitions in your textbook. Diagonal is both upper and lower triangular, and I know we talked about diagonal matrices, or at least gave you an example of one. Let's see if we can find it. It might be back a little bit more. Okay, the definition of lower triangular is that it's a matrix in which all entries above the main diagonal are 0. Now, I think these are hard to remember because your definition is, your name of it is lower, but in the definition, it talks about above, okay? So a lower triangular, first of all, triangular matrices must be square, And so it talks about that as a square matrix. And this is on page 79 in your textbook. But an example of a lower triangular matrix is this. Okay, so I think of it, instead of using their definition that all entries above the main diagonal are 0, I think of it, I have to remember it as lower in my brain. Anything that's not 0 is in the bottom, and that's how I keep it straight in my brain. So looking at this particular one, here's your main diagonal right here, 1, 2, and 3, just as an easy one to remember. Everything above that is 0, and so this is called lower triangular. Okay, you'll also have one that's upper triangular that works exactly the same way but in reverse. Upper triangular says that all entries below the main diagonal are 0. Okay. So that's an example of an upper triangular. Okay, and again, in my mind, the way that I keep it separate is that all of the values that aren't 0 are above, are upper, and so that's how I think of it. Now, they go on in that textbook to say, somewhere through there, maybe on the next page, that a diagonal matrix is both upper and lower triangular, which means that everything above the main diagonal and everything below the main diagonal are 0. Now, where does this come into play? For us, it's not going to come into play because we can only cover so much in a semester, especially a hybrid semester. But this, like I said, is on page 79 in your textbook. So if you wanted to learn more about it, when we're talking about factoring matrices, I factor them as a product of elementary matrices, but you can also factor them in a way called LU, which stands for lower triangular, upper triangular. And so they show you how to do LU factorizations on page 79. And that's not something that's on our syllabus, and so we're not going to cover it, but that is what they mean by triangular matrices there. All right, so as far as that part on your study guide, you can, I'm not going to ask you anything about upper and lower triangular. On your study guide, underneath upper and lower triangular, it talks about equivalent conditions. And I gave you equivalent conditions on one of your handouts. So you'll have that in your notes somewhere, but it's also in your textbook on page 78, and it says Theorem 2.15, equivalent conditions. I won't ask you to know all of those equivalent conditions, but I will ask it on this test and the next one, test 3. And so how I usually ask it, or how I will ask it, is let's say that A has an inverse. Tell me 3 things you can consider about A. Or I might say, let's say that A's determinant is not 0. Tell me 3 things you can tell me about A. And so any 3 things on that list, including that it's square, will be valid answers. Okay, find the inverse. Okay, number 17 on your sheet says use the inverse to solve. Okay, and so it looks like this. Doesn't look like that. Let's try again. Now, I am very specific because there'll be one like this on your final as well, because this is specifically mentioned on your syllabus to use an inverse to solve a matrix. Now, we solved these on our first test. We've solved these in college algebra. It's just a basic system. And so you'd say, I could multiply the top row by 7, and I can multiply the bottom row by 8, and I could solve this out by process of elimination by addition, which you could. And that's a way to check your answer. But that is not what the directions said. So the directions for this said you have to use an inverse. So make sure you pay that. That's the only time I'm real specific, because as you know, most of the time I'll say, as long as you get there, I don't care how you do it. This is the one time this semester that I'm very specific. So the way that this one would work is this way. I would set it up like this. I don't like these numbers. I'm going to double check it and make sure I copied it right. Something doesn't look quite right to me. Let's see. 8, 5, negative 7, negative 5, negative 9. I guess so. So what you're going to do with this one is you're going to find the inverse. We're going to call this A right here. You're going to find the inverse of A, whatever it is. It's going to give you negative 40 plus, it's going to be something over negative 5. So you're going to get this inverse and you're going to multiply it right here. Well, when you multiply this part right here, those are going to cancel out and give you xy. And so that's how we're going to solve it. So whatever your inverse here, remember you got to multiply it on the left side, because if it's on the left side of this, it's got to be on the left side of the negative 911 one. And so you'll multiply that, and that'll give you your two answers. So make sure you work that one on your test in that fashion. Okay, are these elementary? So we talked about those pretty well. 19, and then you have 20 on the back. Find x so that the matrix is non-singular. Also read your directions carefully. Sometimes I'll ask you find x such that the matrix is singular. So sometimes I'll reword it. And remember, you don't have 21 this time. Do you have any questions or anything that you would like for me to visit from worksheet 2? Go ahead.
For number 20, is this the kind of answer where x is not equal to 8?
Yes. That's right.
Okay. So like saying what, like kind of alluding to what would be equal to x.
It's kind of like a domain question. So you could write it like that, x is not equal to 8, or you could write it negative infinity to 8 and then 8 to infinity. You could also think about it that way, because you're throwing out every number except for 8.
But like an answer such as like x equals 3, that wouldn't count, I guess, right?
That's not what I'm looking for. That doesn't mean that you couldn't argue that and say, you said it. So that also might make me reword the problem to say, find all values for which x is, for all values of x for which a is non-singular. But yes, if you said x equals 3, I would have to give you credit for that the way it's currently written. But that's not what I'm hoping you would put.
Let's see. So you want us to put in a domain function?
No, I don't want you to put x is not equal to 8.
So for, let's see.
Hold on, does that make sense? So the correct answer for number 20, if you looked at the study guide, was this. But if you put it as a domain, I'd give you credit. But I just mainly wanted you to say the answer can't be 8 is what I'm looking for.
Yeah, I think
Go ahead.
If I remember class, that's how you wrote that kind of answer.
Yes, okay. What was your other question?
Let's see. For equivalent conditions, yeah, I think I know you covered over this, but what was it that we were supposed to?
Page 78, theorem 2.15.
It's on your 2.4 notes as well. And say, how does this apply to the test?
So if I ask, that's what I said, I'm going to give you one of those and you don't have to answer all of them, but I might say, okay, let's say that A has an inverse. What other things could I conclude? Let's say the determinant is not equal to 0. What other things could I conclude?
Oh, and maybe my answer for number 8 maybe could work. Number 8 on the homework.
Yes, it should be number 8. It's exactly like number 8 on the homework.
Yeah, that's this is what I said. It's not exactly like 3 chosen from this list. So I said it's a non-singular matrix. It's a square matrix, and determinant is not equal to 0.
Okay, so let's go back to your question, Joseph. You said, what are we looking for with that? What you wrote on your paper is what we're looking for. Does that answer your question?
I just want to make sure I know all of what's going to be on the test.
Okay. So you take your time to write that in there? Or you want to write the theorem on your paper? I would write, don't write what's on your homework though. Write what the theorem. So if you look in your notes on the theorem, That's it right there. So that's what I want written there. So those are your equivalent conditions. So if you write 1 through 5 right there on your paper, you'll have it. There you go. All right, while he's doing that, do you have any other questions on the worksheet? All righty, well, your test is going to be Wednesday. You don't have any other homework sets due this week, so that's your only, your test is your only assignment for this week. You do have a homework set though, so if you want to turn that in, I'll take it. Okay, and while we're finishing up on that, we're going to go ahead and start chapter 3. We're just getting a little bitty bit out, and I left all the stuff on the copier, so I'm going to run and go get that really quick. Nope. I don't trick you. Okay, so the question was, are there any questions on the test not on the study guide? No. If it's on your test, it's on that study guide. Are there any other questions with the test? All right, we're going to move to, we're going to do this first.